Hey everyone, it's Miss Ellett, and I just want to do a quick review of equivalent fractions because it has been a long time for a lot of adults, if you're not in the world of elementary school teaching, that you probably don't remember all the stuff they're starting to bring home on fractions, and your brain is going to decimals, and that time you had to leave a tip, and anyway, long time. It's been a long time for most of us, unless you're in their shoes. So equivalent fractions are fractions that have the same value, but they have different numbers of parts. So I don't have a tripod or anything. I have a selfie stick. I didn't bring it, but we're going to make do with what we have. So I traced the sticky notes to draw 4 squares exactly the same size. And I'm going to cut them in different ways and show how they are all the same amount, given the amount shaded is going to be the same regardless of the number of pieces. Anyway, so the first one, I'm going to cut it right here. I'm going to go from corner to corner, and I'm going to very quickly shade one piece out of 2. And right away, all of us remember this is equal to, when I said 1 piece out of 2 total pieces, that equals 1/2. So if I take this same square, same size square, and cut it, and my drawing's not perfect, but let's pretend, shading that same amount, the same amount. If I were to cut it again, not a videographer, and if I were to cut it the other way, okay, so now I have 4 total pieces. I've got 4 triangular pieces, and we would all agree that 2 of them are shaded. So that shows us that an equivalent fraction for 1/2 is 2/4. Well, what if I took that same square and I cut it and I shade it, shading the exact same amount every time, not changing the amount. That's what makes it equal, is that's the same amount shaded. Of course, this could also be parts of a set. If I cut it the other way, that's our 2/4. But what if I cut it again? Okay. And then everyone would agree with me that I have 1, 2, 3, 4, 5, 6, 7, 8 pieces. And the number of pieces, or the total in a set, is always going to be the denominator, the number on bottom. The numerator is going to be the number shaded, almost in every problem. 1, 2, 3, 4 shaded. And that again shows that our original 1/2 is the same thing as 4/8, is the same thing as 2/4. But what if I did it a different way? Again, starting with that square cut in half, I'm going to shade the same portion that I've been shading. I'm not shading it as well, but it's the same portion. I'll shade it a little bit better. Shady, 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 shady. A little bit more shady shade. Now, what if I split each of those halves into 3 pieces? And because I did triangles, it's not going to be perfect. But let's pretend. Use a little bit of imagination. Let's call these equal sized pieces, even though they obviously aren't. I should have done a circle. It's too late for that. Let's go with it. So let's pretend that these are equal pieces. I know, they're not, clearly. But then we would still have 6 pieces total, because that's how many pieces we've cut with our 3 different lines, because we have a cut here, number 2 goes that way, the third one goes that way. So now I have 1, 2, 3. 3 shaded pieces out of 6. Again, the same portion of that square is shaded, so it's still a half. No matter which way you look at it, no matter which way it's cut, it's still going to be 1/2. So that is a basic review of equivalent fractions, and I should be able to post this video today, and then I should be able to do another one tomorrow about adding and subtracting fractions. Thanks. Have a good night.